Okay, we are live now. We start with the class. So today we will discuss some very important concepts of maxima and minima
Hmm.
in this what we say for double like multiple variable functions or
Hmm.
multivariate calculus. So maxima and minima in multivariate calculus. So we will look at some important questions. So the first question in front of us. What is meant by stationary points? What is meant by stationary point?
Hmm.
What is meant by stationary point? A comma B of function f x comma. So we have a function of two variables x and y, and we have to check what is stationary point A comma. So do you know what is stationary point?
Um, Stationary points of a function.
Yeah,
I know breaking points where the function changes.
yeah.
Stationary
Okay,
points, I guess the function does not change. Like any 2 points where it's in
okay,
between the function, I guess I'm not sure, sir.
okay. Fine, it's fine. Let us discuss.
Um,
So if I talk about stationary point, like two, three properties are there. We can start with the first property that stationary point is a point
hmm.
where the partial derivatives of the function with respect to both x and y are zero.
Okay.
Okay? Yeah. So let us look at it. What is stationary point? So you have to write like this. If you get a question like this, what is meant by stationary point of f x comma y? You have to write like this.
Hmm.
Point where the partial derivatives. Point where the partial derivatives of the function with respect to both x and y are zero. You know that like when we have a function of many variables, like function of two variables, in order to calculate maxima and minima,
Yeah, we equate it to zero, right?
yeah,
Then
we
yeah,
calculate the partial derivative.
I
Yeah,
have differentiated with xy, then we equate it to zero.
that is it.
That's all.
So now mathematically, what we can say that mathematically we can say, I will write it. Mathematically we can say that fx a comma b
Hmm.
is equal to 0.
Hmm.
And see here fx is the partial derivative of the function with respect to x and the partial derivative of the function with respect to x should be 0 at the stationary point, isn't it? So f of x at a comma b should be 0. And similarly, partial derivative of y with respect to function at the point a comma b should be 0.
Hmm.
Got it?
Yes, sir.
So stationary points are those points at which the partial derivative of the function with respect to both x and y are 0. Like
Hmm.
f of x, f subscript x, it means that partial derivative of the function with respect to x we will calculate, and at point a comma b when we substitute it, like x is y is equal to b, so
Hmm.
we will get 0.
Hmm.
So this is the meaning, like
Got it, sir.
yeah. So just for understanding here, we have used this f of x. F. So the f of x is the partial derivative function with respect to x. Because this is a theoretical question, so you have to write it like the same way I'm writing to get good marks.
Yes, sir. I'm writing.
F of x with respect to x. And similarly, what is f of y? Partial derivative of function with respect to partial derivative with respect. Now let us look at some more properties of stationary point. So at stationary point, so let us try to feel the, like, see, mathematically so we got, but what is the significance of that, or what is the intuition behind this? So the idea is that see, what is the meaning that if I do the partial derivative I get 0? It means that the function is not changing by changing x. Like at that point, the function is not changing along the x-axis also and along the y-axis also.
For a certain, like the limits also, we will. Okay, that is for later on.
Yeah. So let me mention it. Yeah. Yes.
Wait,
So
so
the
take a
yeah yeah
function,
yeah yeah. Tell.
we differentiate it
Mm-hmm.
twice. I mean, we differentiate it, then we substitute the values, but and the function is not changing.
Yeah.
In the limit a comma b after we differentiate it and
Yeah
substitute,
yeah yeah yeah.
not integrate, right? This is differentiation.
Yeah, differentials.
Okay.
Because at that point at a comma b, at point a comma b, the slope is 0. And if the slope is 0, it means that at that point the function is not changing. And
Mm-hmm.
hence it is called stationary point, because at that point the function became stationary.
Yeah.
Okay, so a comma b is at that point where the function becomes stationary. And since function became stationary, the partial derivative with respect to x and with respect to y, it has to be 0 at that.
Mm. Okay, sir. Got it.
So I can say at stationary point, at stationary point A comma B, what happens is that the rate of change of function along the x direction and y direction. Along the x direction and along the x direction and y direction is 0. So this is the significance of stationary.
Hmm.
Now, around the stationary point, three things can happen. Like at the stationary point, three things can happen, and that is what this is. At stationary point, three things can happen. The function may have a local maxima.
Hmm.
A function may have a local minima, or it can be a saddle point. Like the stationary point can be a point of local maxima. I can write it like this. At a stationary point, or to be more precise, I can write it stationary point can be a point of stationary point can be a point of local maximum. Stationary point can be a point of local minima. This stationary point can be a saddle point. Now let us try to understand what it means with the help of a figure.
Hmm.
Just as we can see in this figure, So this is the local minima. So in local minima, what happens is that the function reaches a trough or a dip, and in the local maxima, like at that point, the slope is zero, but a maximum is reached, a peak is reached, and then we will go down, isn't it?
Yes, sir.
And in local minima also, the slope is zero. So these are stationary points. So at stationary point, the slope is zero. So either it can be a minima or it can be a maxima. And that stationary point can also be a saddle point. In saddle point, what is happening is that the function changes direction, but it is not neither a minima nor a maximum. Like what is happening at saddle point is that the in one direction it is moving upwards, and in the other direction it is moving downwards. So something like this.
So, it's like giving 50 newtons of force on the both sides, so there is no moment. Like it gets balanced, something like that.
Yeah. So saddle point, you can say that at this point, neither maxima exists nor minima exists.
Okay,
At,
sir.
at saddle point, neither maxima
Hmm.
nor minima exist.
Hmm.
Isn't it?
Yes, sir.
At saddle point, neither maxima nor minima exist.
Hmm.
So as we can say, this is the saddle point. So we have something about something that. So now we got an idea. So the idea is that, see, definitely, once again, if we look at the stationary point, what are stationary points? Stationary points are those points at which there is no change. At that point, there is no change along the x direction also and the y direction also. It means that the partial derivative with respect to x at that point is zero. Partial derivative of the function with respect to y at this point is zero. So a stationary point can be either a point of maxima, local minima, or saddle point. Now, definitely, how to check whether the stationary point is a point of maxima, point of minima, or a saddle. That is also important discussion. How we will check that. So for that, uh, there is a second order derivative test, and we also call it Hessian test. I will write. So this is the last point for this question. So if you are given this theoretical question, you have to write all this.
How many marks is this question for, sir?
I think it was for 3 weeks,
Okay.
but you have to write all this.
Hmm.
To score 3 marks also, you
Yeah.
have to write so much.
Even solving I'll do happily, but this is
Yeah. But we can't expect like you can get a theoretical question so because we are solving a PYQ.
Yeah.
The exact nature of the stationary point.
Hmm.
The exact nature of the stationary can be determined Easy. Second order derivative test. Now we will see what the second order derivative test is. So the interesting thing is that now with this theoretical understanding, if you get a numerical also, at least your concepts will be clear. Like at least you will get a good revision to how to solve the problem.
Yeah.
Because what the question, they can ask a question like this, they will give a function and they will tell you to check the stationary point or find the stationary point for this function. So now you know that, oh, I have to find the stationary point. For that, okay, this function is given. I will first do the partial derivative of this function with respect to x. I will get one equation. And I will do the partial derivative of function with respect to the y. I will get the second equation. Both the equation I will put equal to 0. For two equations, I will put it equal to 0. And I will solve for x and y. And the solution I will get, the points x and y for that, for which the equation became 0, that will be your stationary point. That will be the point where the function will either have a local maxima, local minima, or a saddle. Yeah, 10.
Yeah. No, same thing, sir. Yeah.
Okay, nice. So I hope this is very clear to you. Okay, nice. Now we can look at the next question, because we are discussing the PYQs. So the next question which has been asked in the exam: state the condition for the stationary point. State the condition for the stationary point A, B. So A, B is the stationary point, and this is the stationary point of function fx, y. So I have any function fx, y. A, B is the stationary point. I have to state the condition for which the stationary point becomes the maximum, or to be the maximum. Isn't it? So now in this question, basically, they are not asking about the stationary point, but they are telling that, okay, we have a stationary point A, B of a function. Tell us the condition for which the stationary point has to be the maximum point. When the stationary point will be the local maxima, point of local maxima, what will be the condition for that? That we have to discuss. Let us see how to do this. So whenever we are dealing with the stationary condition, we have a first derivative test, the second derivative test, or we call it like the first order conditions and second order conditions. Now let us see what is this first order condition. First order condition is that first derivative should be equal to 0 at that. So whenever we will be solving, if the stationary point is given, first verify whether that is the stationary point for this function or how we will verify it. We will do the partial derivative with respect to x, with respect to y, put the stationary point and check whether it is 0 or not. If it is 0, we are convinced that okay, this is the stationary point of this function. So the first order conditions we are discussing. So first order condition states that f of x a comma b should be equal to 0. Like the partial derivative with respect to x at that point a comma b should be equal to 0. Partial derivative with respect to y at that point a comma b, it should be equal to, isn't it?
Yes, sir.
So this is the idea for the stationary first order condition. First order. Now we will look at the second order conditions. That is what is something new we will be studying. This second order conditions will help us to determine, okay, this is the stationary points. With the second order conditions, we can determine whether it is a point of maxima, point of minima, or the saddle point also. Pakka, you will get questions from this topic. For sure, 100%. Like, a question can be anything, but same concepts will be used. And questions are doable.
Yes, sir.
So second order condition. So let us see how to do that. So for this, we have to do the double derivative, isn't it? So this is the double derivative of the function with respect to x, and we are already aware of this notation fxs. It means double derivative of the function with respect to x. Then we have fyy. This is the double derivative of the function with respect to y. And we have fxy. It means that we are doing the derivative of the function first with respect to y, for example. Then whatever derivative we got, we are once again doing the derivative of it with respect to x, isn't it?
Yes, sir.
So what you will get? You will get something. So we are already aware of these three notations, and this is what you have to do. So now you got an idea that in order to determine the nature of the saddle point, nature of the stationary point, whether it's a point of maxima, minima, or saddle point, I have to calculate fxx, fyy, fxy. And based on that, I have to calculate the Hessian determinant. What it is, let us see. Now we have to calculate the Hessian determinant. Hessian determinant. Hessian determinant.
Okay. Like f of xx y a square. Some of this is formula, right?
Yeah, you're right.
Something.
Yeah. So let us memorize it. Very important formula. You should be knowing it. Like you should remember this. So d is equal to f of xx.
F of y, I remember little bit.
F of xx at the stationary point into f of yy at the stationary point minus f of xy at the stationary point whole square. So this is the Hessian determinant. Now see, whatever d we will get, According to that D, we can find something very useful.
Mhm.
Let us see what we can find. So see, three possibilities are there, or four possibility. So let us discuss all those four possibilities. So let us suppose D is greater than 0.
Mhm.
Like this determinant, we got greater than 0. And also f of xx at the stationary point is less than 0. If these two conditions we get, then we will say stationary point A comma B is a local maxima.
Mhm.
We will say that stationary point A comma B is a local maxima. Isn't it?
Yes, so.
Now we can have this capital D greater than 0 and this f of xx. So now we got an idea that in order to determine the nature, we are comparing, like we are checking for capital D and fxx.
Mhm.
It is also positive. So if both are positive, if capital D is also positive and fxx is also positive, what it means? It means that A comma B is a local minimum. And you have to remember all this. Because in the exam, very easily you can expect a maxima minima question.
Ah. Oh,
And
this I can remember because I remember doing it in class. Yeah.
yeah, and we will practice also.
Ah.
So these are like free marks.
Mhm.
I think 10 marks, so definitely more than that can also be. So 10, 15 marks, very easily we can
Yeah,
score from
my
this.
teacher was saying in double integrals, more than evaluating the integrals, if there is more mark for substituting the integrals. And the worst part is, they are expect you have expected to draw a graph for the function. So every graph I should know.
Okay, okay.
Yeah.
Okay. That we will discuss. That will be discussed. Okay, this is so interesting that if the determinant, if the Hessian determinant is negative, then
Mm.
the stationary point has to be a saddle point.
Mm.
Then the stationary point. And in order to pull the legs of the student, there
Mm.
can be a condition where D is equal to 0. And
Uh,
uh,
okay.
then if D is equal to 0, then you have to say that test is inconclusive. If it is an MCQ question, if it is a multiple choice question and you got D is equal to 0, so you have to tick where a test is inconclusive, and if no option is given, you have to say none of these.
Mm.
Like one option is that point of local maxima, point of local minima, saddle point, and none of these. You have to tick none of these because
Mm.
if D is equal to 0, we cannot say anything about the stationary point. It can be anything because this test will not give
Give.
us any result, isn't it?
Yes, sir.
So this idea is very clear. So according to this question, they are asking the condition for the maximum point. So we can conclude the answer. So see, that is what now. So we gave all the, because in exam we have to express. We have to express that, okay, I know this also, I know this also. They're testing your understanding. So you have to write all this. And in the last, you have to give a conclusion that, okay, they are asking for the maximum point. You just give a conclusion for the maximum point. and you will say something like this. For the stationary point A comma B, for the stationary point A comma B, to be a maximum, we require so what are the conditions? D should be positive. F of XX AP should be negative. This is the final answer for this question.
How many theoretical questions do we have, sir?
We will have many. Like now, we will discuss one more saddle point. That's it. Then we can practice.
Then we'll go to numerical side. I'm waiting for that.
No, wait. Please. Let us complete this properly. We have to do each and everything. We have to do it. We have to do theory also.
We will do it, sir. The thing is that so much theory.
Wait. Please let us complete this. We are live. Please. So let us look at one more question. What is meant by saddle point of a function? So what problem arises now? I know what is saddle point, but in the question, if they are asking this theoretical, because I am discussing P by Q, I can show you the question paper also. This same question is been asked in some of the previous years. So what problem we might face is that we might get blank. Like if now if they are asking you, okay, tell what is meant by saddle point of a function fx comma y. We will get blank, then we will recall, we will get to know something, we will write something. But if it is of 3 marks, to grab those 3 marks, whatever I am writing, that should be the way. And if you express in that way, then definitely you will get good marks.
Yes, sir.
So that is the purpose of that. So two purpose we are solving. First, we are getting to know how to write answers, and also we are doing a revision of the concepts. That is very important. What is meant by saddle point of a function? F of x comma y. Now let us see. Let us write the answer. So we already know that saddle point is a special point where neither the minima exists nor the maxima exists. So we will write that saddle point. Let us look into what is saddle point. Stationary point. So saddle point is a stationary point, isn't it? Saddle point is a stationary point. So that is why how we have to express it. We have to say that saddle point is a stationary point where the function,
Either maximum or minimum.
No, where the function f of x comma y does not exhibit does not exhibit a local maximum or a local minimum. Second, at a saddle point, because for 3 marks, you also can understand that if you just write this one point, how we can get 3 marks? It's not possible, isn't it?
Yeah, it's just a-
That's the purpose. That's the purpose of this class. Because interestingly, this question
uh,
it carries 3 marks,
oh.
and that is concerning for us.
Mm-hmm.
Because what else we can write now? Because we know
I'm
that okay,
pretty sure sometimes this type of question will come.
yeah.
Yeah.
Because they will be testing your understanding.
Mm-hmm. Yeah.
They will be testing your like how much you know about saddle point.
Yes, sir.
So that's why we are doing this exercise.
Mm.
At a saddle point,
Mm.
at a saddle point, the function behaves at the saddle point, the function behaves differently in different directions. Isn't it? So this we have to write. And here also, two more things I will mention. So at that saddle point, at that particular stationary point, the function behaves. So in one direction, it is behaving differently. In the other direction, it is behaving differently.
Mm.
So at the saddle point, in some directions, at the saddle point, in some directions,
Mm.
the function increases. The function increases. In other directions,
It decreases.
in other directions, the function decreases. That's it. Now we know that at maxima, function increases. Like since the maxima function increases, becomes stationary,
Mm.
and at minima the function decreases and becomes stationary. So here we can add one more point. Like in some directions the function increases, like at maximum, like at the maximum. In other directions the function decreases, like
Minimum.
at a minimum. And this so like you write it if you have time. I will just tell you there is a reason to call this point saddle point,
Mm.
and that reason is the horse saddle. So
Uh,
horse saddle is basically the seat.
yeah, where you sit on. Yeah, yeah, I have seen.
Maxima.
Uh,
So
why,
that is,
why horse saddle?
yeah. So that seat is
Similar.
like I'm not drawing it exactly, but yeah. Okay, I think I have the diagram. Yeah, it is similar.
Hmm.
It is similar to this. The hot seat. Like that we can Google also. We can look at it, but it has something like that structure.
Hmm.
And inspired by the horse saddle, this point is called as saddle point.
Hmm.
Now we have to give one more point to get 3 marks, because now we are eligible to get 2 marks because 2 points we have written,
Hmm.
or 1.5 marks,
Hmm.
because until now mathematical condition we haven't written now, like when the point will be saddle point, that we haven't written. So let us do that mathematical condition. So that is what will give us good
Hmm.
marks. Mathematical condition for a saddle point. So the same thing you have to do. The first order condition, second order condition. First order, first order condition. And what's the first order condition? F of x at the stationary point a comma b should be equal to 0. And we here we haven't specified a comma b. So first you have to write, something about the stationary in this context. So you have to write like this. Before first order condition also you can write here, or taking a comma b, as stationary point, taking a comma b as stationary point of f of x comma. Now what is the first order condition? F of x a comma b should be equal to 0. Like the first derivative or the partial derivative of the function with respect to x at the stationary point has to be 0. And partial derivative of the function with respect to y at the stationary point has to be 0. So this is the first order condition that you have to show. Then we have to show the second order condition. In the second order condition, you have to write, like we know that we have to do the double derivative. So let us do that. F of xx, we will calculate, that is the double derivative of f with respect to x. Then we will calculate the f of y, that is the double derivative of f with respect to y. Then we will do the f of xy, that is double derivative of f with respect to x and y. Then we will calculate the Hessian determinant d. As per, like we already know that the second order condition only, we have to find the Hessian determinant d. And what is this? This is f xx at a comma b. The formula for Hessian determinant, f y a comma b minus f xy a comma b whole square. So Hessian determinant we calculate. Then for the saddle point, d has to be 0, less than 0. D has to be negative. So I will write if d less than 0, if d is less than 0, then the stationary point a comma b is a saddle. And if you have time, you can write all the, you can state everything like d greater than 0, all that, like maxima, minima, saddling, music.
This exam I wouldn't be having time because it's
Yeah,
only for 1 hour 30 minutes. It's more like
yeah.
oh,
No, it's fine. Like it's your call. I am just telling.
yeah.
It's your call. Okay. So this is how you have to do. If you do all this, then you will get like marks, no?
Yeah.
So this is done. Now we can do
Questions.
one question we will do.
Ah.
Like let us do one question. So here for f of x comma y is equal to x square minus y square. This is the function
Ah.
for f of x comma y is equal to x square minus y square. the point 0, 0 is option A, local maxima.
Minima or
Local, yeah, local maxima point, local minima point. In exam, you can very easily get such questions,
Hmm.
either in the form of MC, any form they can ask. Saddle point or none of this.
Hmm.
So please try this.
Yes,
Please
sir.
try this.
Just a second. Uh, okay, sir. I shouldn't be getting this doubt, but I got this doubt.
Mhm.
Uh, f of xy, first you have to do x, then y.
F of X. Yeah,
Okay.
yeah, yeah, you can do that. So see, first y then x, f of x y.
Hmm.
First you do the partial derivative with respect to y. Whatever you will get, do it with respect to x. Okay.
Hmm.
Yeah. You do, and I will just write the theory.
Yeah.
Like in order to solve such problems, like it's
Minus
carrying.
minus 4 is the answer.
No, you have to tell A, B, C, D.
A, B, C, D.
Like
Oh, the options
yeah.
less than 0. Okay, D is less than 0, so it's not saddle point or inconclusive. That two options I've eliminated. Um, f of x is it is local minima, maxima. I got -4.
No, you have to tell A, B, C, D.
Okay, A.
Okay, let us check it. So in the exam, what you have to do, you have to write like this. No? First, I'm telling you the way to write it, to solve this. So
Huh.
first order conditions. In first order conditions, you get that f of x a comma f of x 0 comma 0, f of x 0 comma. So that is partial derivative of this function with respect to x. It will be 2x. So 2
Hmm.
into 0. It is 0. then partial derivative of y, or because we will be needing double derivatives. So first I will do f of x is 2x. Then I will do f of y.
Hmm.
That is partial derivative of function with respect to y. It is minus 2y, isn't it?
Hmm.
Then I can say that in the bracket here f of x 0 comma 0 is equal to 0, and f of y 0 comma 0 is, I can say that hence first order conditions. You please make a note of this also. Why? Because try to solve like this the way I'm doing.
Hmm.
Hence, first order conditions. In first order conditions are satisfied.
Hmm.
Now we will check for second order conditions. For second order conditions, we have to find f of xx, that will be equal to 2, f of yy, that will be equal to minus 2, f of xy, that will be this. So first the function I will do the derivative with respect to y,
Hmm.
then with respect to x. So it will be 0.
Hmm.
Isn't it?
Yes, sir.
And then I will do the Hessian determinant.
Oh, yes, sir.
You have to write like you have to write it below. Next page. This presentation is very important.
Hmm.
Now straight away I can say that Hessian determinant. So first write the formula.
D is equal to f of xx into f of yy minus f of xy whole square. And substitute table.
Hessian determinant
Hmm.
is f of xx a comma b f of y a comma minus f of xy a comma b square. Isn't it? Now if we substitute it, we will get d is equals to It will be 2 only. Because 0, 0. So it's a constant function. So it either depends on x nor y. So f of x 0, 0. So I will write one more step I will. Because here the stationary point is 0, 0.
Hmm.
Now see what it. So it will be 2 only. 2 into minus. The Hessian determinant is minus.
So this took so long. I mean, okay, yeah, so you have to present it, but I
Yeah.
found like 2 minutes and so much time.
No, you have to. Because let us suppose this question carries 5 marks.
Wait, no way.
Definitely.
No, no, no. I said no way.
No,
This is
no,
very.
please. See, whatever I am doing, please follow this. Please. Yeah, we are live. So, minus 4. Now, see what you have to. Now, according to the condition, if d less than 0, according to the formula,
It's either minima or maxima. Then we have to check.
wait.
Oh,
So that's why I say, na, be careful. Because if d is less than 0, no, then it's a saddle. If d is less than 0,
oh,
please.
wait. So then f of x x y y.
If d is less than 0, then
Uh,
0, comma 0 is a saddle.
uh,
Okay?
such a silly mistake I did.
So please, that's why see whatever we are doing, do it patiently, and everything is important. Don't never be in hurry in maths because you will be losing 3 marks. Like see, -4 you got, that was right, but here you made it. So be very careful with formulas. If d
Hmm.
is less than 0, then 0, 0 is a saddle. So C is the right option.
Hmm. So next question.
Very good.
Okay.
Yeah. Now we have ended the stream. Yeah, now it will be